thank you. I'm Laura Hart. I'm with Lockheed Martin, but I'm representing the OMG Model-Based Acquisition User Community. And what that community is well, first I'll start off with what is model-based acquisition? It's the use of models and digital artifacts to communicate RFPs instead of text-based information. And the reason why this is so important is because we've been seeing this for years now. And it can be very disruptive to both the government, as in this case, we're kind of focusing on the DoD type of contracts, but we think when we're done, we can extend that to just industry in general. But right now, we tried to scope it, and it's DoD contracts, and we have been seeing the use of models in RFPs at different levels for probably the last 8, maybe even longer years. It's not that it's not, there's pockets of excellence where they're doing really good things, but they're different. And every single time, especially if you're a large supplier and you're have several different customers, it's hard to adapt to their different approaches. And it's also hard for them because each time they're trying to create one, they're trying to figure out how to do it again. So we come to the point where, hey, we're all doing this. Let's get together and try to create some standardization. So there's a difference between a standard, UAF is a standard, SysML is a standard, there's lots of other standards. We're trying to create some standardized approaches, patterns for using standards in the form of reference architectures and also in the form of something called domain overlays that will standardize the way that we approach different concerns, like how do you address most, how do you evaluate it or grade it, or IP and data rights, what's this consistent way of communicating that type of thing, or one that we see people create over and over again, airworthiness. What are the properties that need to be exposed in the system to be able to address airworthiness? Or nuke surety, certifying a nuclear system. These things get repeated over and over. We even used to do the same thing back when we would try to ingest different regulations. We would do it indoors, and we're doing the same thing in the models now. So how do we standardize that? That's what this group is trying to do. And who makes up this group? This is where even the mission engineering work that y'all were talking about, and talking about how you're going to communicate across the various service, this might be the kind of organization where you can do that, because we are we are starting to work across the various services, DoD CIO, the OUSD, RNE, and the ANS, because we realize that acquisition is also not just an engineering problem. We need to be able to communicate with the capture teams and the legal and the acquisition specialists. So we're trying to be broader than just, okay, we're creating a model. We are doing acquisition, and the model is central to it. How do we make sure everybody gets what they need? And as you can see here, we also have a participation from DAU. We're working with them because we want to make sure that as we're developing different things, that they're also, coming along with us, both, contributing and being able to take away what we're doing. One of the things that we really, and there's probably around 200 people across all these different organizations, including FFRDCs. And I also want to stress that, the leadership is myself, Ray Anderson from MITRE, and Tony Nolder from the aerospace company. What we're really doing here is trying to move systems engineering to the left. So we don't want someone to think that they're just going to, or the government, we don't want them to take their existing textual documents and then just shove them in a model and give them to us. First of all, the quality won't be there, and they may not actually get the benefit of the model. So we're really moving systems thinking and systems engineering to the left, addressing the whole life cycle, but doing acquisition. So down at the bottom there, you know, when later on, when you ask me, what about the whole life cycle? Just reminding you, we're trying to address the whole life cycle, at least the, you know, the expectations during the acquisition. So we had some the Air Force was in particular said, hey, we really like this, but how are you going to institutionalize it? So we became a formal group under the OMG as a managed community as of September. So we have, you know, we inherit the process and procedures of the OMG. And when we did that, we were also moving our knowledge repository from the MITRE site, which was fantastic. It was a very collaborative Confluence site, and all the work that we did kind of out in the open. We're moving it to an OMG repository called Causeway. This is just to kind of show when we first started, it wasn't just about creating the model, it was about creating the whole infrastructure and the enabling activities that you need to be successful as well. So you'll see here that we kind of broke up the work into research. What's out there? What programs have already done this? What was successful? What wasn't? And we have some information on our Confluence side of what we learned. Where's the reference material? Let's start with everything that we can find that we don't want to recreate things, and then looked at, well, you know, we need to like look at the domain model. Like, what are the concepts that we have to represent in this activity? And I'll show you our concept model. And then in our implementation, actually creating exemplars showing how we're using these things. And then we had one of the services said, oh, well, who's going to own this stuff? Is Lockheed going to own this stuff? Like, no. This some of this stuff you're going to own, and some of it might actually end up being an exemplar that's delivered as a non-normative part of like the UAF specification, you know, with a user's guide. Then that brought up the whole, we're creating all this stuff. How are we going to manage it? If we're actually creating these reference architectures, we want to be able to have distributed repositories and be able to discover and maintain and catalog things appropriately. And Matthew mentioned that one of the spinoffs is we're looking at what are the standards right now that could support us. Maybe they don't do what we really want, but can we take one that's existing and update it quickly and get it out and approved quickly? And that's one of the tasks. So we're moving into this new managed community, and this is just showing you what the new site looks like and how we organized. You saw those activities we have. We kind of organized around sub-working groups. So you'll see here, I'm looking for a mouse. Yeah. We have the top level model-based acquisition user community. And that's really, that was our driving force, is to start using these models during acquisition. But it really is looking at how to use, to burn down the technical debt by starting the MBSE process prior to acquisition. And so we've broken down into these various groups. The ones of importance here are like the architecture working group, where this is where we're developing those concept models on what needs to be represented. I'll show that to you in a second. You know, the reference architectures, looking at different patterns for doing analysis. Of course, you know, the use cases, the use case of creating an RFP, addressing one, grading it, and so on. So, oops. And then, so those use cases. And in the slides, you'll see that there's some support material that kind of addresses how you use these artifacts at different stages. Like, how do you use them? How does the government use them prior to RFP? How does the suppliers use them, afterwards? And how are they graded? How do you show compliance? That type of thing. These use cases are going to inform this other product that is just, if we don't do this, we shouldn't do anything. And that is provide role-based guidance on how to use these artifacts. If we don't have that, we'll have a bunch of stuff and people will say, oh, that's cool, and no one will use it. So we are looking at role-based guidance, and not just for the engineers again, but for everyone that's involved in the process. Then, reusable assets. There's this working group, there's multiple parts to it, and we may actually even split it up a little bit. One is about what standards exist. The other is, let's go and actually kick off a new standard within the OMG called RAS version 3. And, it is actually an actual standard where this is it's kind of like, how do we apply the standards? So one of the other pieces here, we're trying to figure out where it would belong, would be curating existing content for evaluation. So we have to both create content in this group, but we also want to just curate what's out there already. And maybe we bring it in and we can then have it vetted across the services. So the Navy can bring something in and the other services can look at it, and they can kind of, we can kind of negotiate a little bit and see how do we make it so that it's common and extendable, so that we can then make sure it's well formed and put it up in one of these libraries for sharing, that type of thing. The other thing that's going to be critical to successfully doing this digital engineering transformation is our environments. You can't have you can't do digital transformation without some type of environment, but it doesn't necessarily mean that you have to impose a particular set of tools and integrations. And in fact, that would be very limiting to the large suppliers, which, if you just look at the front end set of tools from systems engineering, we think that's hard. Looking at how you integrate some of the systems engineering and mission engineering and requirements and configuration management, and even some of the CAD. But when you start talking about the complexity of these large contractors' design tools in manufacturing and test, and if you start trying to impose too much of you have to use these tools, that could be very limiting. So we're looking at how do we address this from maybe a data standpoint? Contract language. So we're also seeing, and this is a good thing, we're seeing the different services come up with here's an example of contract language we think that would be good for describing that digital ecosystem. Well, we should probably look at that. And this is a really good place for the services to actually connect in a very neutral place. So we've recently gotten a tour from the Space Force that is contract language for a digital ecosystem. And so it's, we're starting to look at that. For those that, some of our challenges, and it's not as bad as, when you're actually doing the models, is some of the models that we want to review might be distro D. And so it kind of limits a subset of people in our group that can actually look at them. So if you look at the big blob here of things that we are doing, we're basically saying that number one thing over here, not number one, that the most important, but it's very important, is this architecture evaluation criteria, trying to provide some standardization on modeling conventions, patterns, these things called domain overlays that allow us to consistently evaluate architectures. And then the thing in the middle, which is this, that is the GFI model that is handed over as the way to represent the system that they want to acquire, called an OAD, Objective Architecture Description. And then, how do you put it all together in an RFP package? And again, that thing that ties it all together, which is down below 4, the guidance. So what goes in that the OAD? We'll look at that in a second. But I also want to talk about, and we spoke about this today in several of the presentations, that there's different kinds of models. There's those structural models that tell you, descriptive models, I should have said, that are kind of emphasize how all the pieces are put together, what data information flows, constraints, and it really provides this consistent whole that the simulation itself, simulation analysis models have to, need to be consistent with. And then we have those other kinds of models that are more specific. They're used for more specific tasks. They're looking to emphasize some performance or reduce some risk through analysis, optimization, validation, but they need to be consistent. And a lot of times those analysis and simulation models are done out of the context of that descriptive system. And so I just want to highlight the fact that we're addressing both. And the descriptive models are in the form of reference architectures in what we're doing. Those analytic or analytic type of models are in the form of these things called domain overlays. And we're making, but they have to work together. And when I say a system architecture model or that descriptive model, I'm not talking about a wiring diagram. In this case, I'm talking about a very rich multidimensional type of model that includes structure, behavior, requirements, constraints, and parametrics. And it's all integrated into this thing called a system architecture model, which is in itself just the evidence of good systems engineering if it's done right. I'll go quickly on this, but we're trying to align our concepts with other ISO standards like 42010 and 4242, and those are still in work. We're still kind of discussing what we're trying to achieve and whether those, trying to influence what goes in there as well as compliant with them to the degree we can be. So this is our concept model. This is kind of like everything on a page. It's not complete, but it's enough to kind of tell you the story that over here in the green is our suppliers. And Aurelis, can you tell me when I have 10 minutes left? Okay. The thing in the green is our suppliers. That's where, Lockheed and Boeing and Raytheon and Northrop Grumman are. And they're over there creating their exquisite model-based systems engineering approach. And then they get a model from the customer and says, here, go, respond to this. And they're like, oh, they want us to use different tools, different processes. What do they expect back? So we're trying to kind of make that that handshake, that handoff between the government giving us a model to represent the system and the suppliers responding to it a little more seamless and take the unknowns out of it. We focus on the problem space and the solution instead of, ooh, who has the prettiest model, type thing. At some point, it would be great to not, it'd be like I'm grading on your PowerPoint skills versus the content. So let's start doing that. So everything to the left though is pushing the discipline to the left so that we can standardize what goes into that GFI model, that government furnished information model that describes the system that they want to acquire. And we're doing that through things called reference architectures. So that purple thing that has the blow up there is the objective architecture description. That's the thing that they want to acquire. And is the GFI model or the logical architecture that, that's basically the specification for the RFP. But we want to provide some guidance on what should go into any good OAD. And so we have in there, you should always have the high-level capabilities, mapped to the operational scenario so you understand how that system is going to be used. You can design a system better if you understand what it's used for, as well as any key performance KPPs that make it suitable for use, as well as any functional or physical constraints, because a lot of these systems already exist and they're block mod upgrades, as well as the requirements. But you can see that this is very high level. So it's kind of a place to then, like in this case, that physical and functional constraints down there could be replaced by the Air Force's air vehicle reference architecture or the missile defense missile reference architecture. So these reference architectures can be hierarchical, but we need to understand how they kind of fit together. And then go over to the DO side. The DO side is about, okay, now if I want to do airworthiness, what are the properties I need? What would I do with them? How would they be applied to the systems so that if I wanted to create, traceability matrix or a table that kind of summarizes the things that are, that I need for evaluating the certification plan. How do I do that easily? And so these DOs are kind of composed like that. So the first bullet, this, go this way again. That blow up there is basically saying, a domain overlay, the way you think about it is kind of, defining your concerns. What are you concerned about? I'm concerned about how I'm going to certify a nuclear weapon. What do you need? I need to know certain things. Is it a critical function? What kind of critical function? Different things. Is it hardware or software? Okay, George, if I gave you all that stuff, what would you do with it? So, what is the logic? How do you capture that information? And then after we do whatever we need to do the analysis, what is the visualization? What's the view? We're calling it an EDID that would make you feel comfortable that it had been addressed appropriately. And then here's just an example of some of the DOs that we've kind of identified, and we're going to have Richard be talking about one where we're looking at how do you measure MOSA. So, and this is a little bit more than just how you measure it. There's this approach to, like, how do you even put MOSA on contract? Looking at the outcome that you're trying to get from modularity, and then making sure that things aren't just modular, but that you get the outcome you expect because you did modularity. Okay, so once again, if you look at this handoff between, let's see if I got the handoff between the purple box, the OAD, and then to the supplier side on the far right, they're going to come up with some type of solution architecture. But you can see how this could be applied within an institution as well, where the suppliers would have their own library of reference architectures, or even product lines that at some point they could, okay, I hate to even say it, but at some point apply AI so that they could look. I know it's just like such a buzzword now. I hate to even say it, but apply some type of logic so that they could come up with maybe a 70 or 80% solution that's compliant with that OAD. And then some of the other, requests that we're seeing is, well, how do we actually do this agile so that so that the government's not just creating this OAD, throwing it over the wall, and then finding out that it's not really what they, there's things out there in the supplier's environment that they already have, they don't even know about. So throw in that little agile piece, and maybe there's the RFI process itself uses these models and this feedback loop. Okay, so I'm going to skip that. So this is where, we're defining what these domain overlays are. We're looking to curate existing ones, vet them, and doing the same thing with reference architecture. That comes up with, oh, we need to be able to catalog these things. And, let's go do this little side, this very important side supporting task, for updating RAS. And this just kind of talks about, when you're creating one of those domain overlays, this is just, you're framing the analysis and why and what is needed. And then you go in and you actually do the mechanics of creating this. So think of a domain overlay. It's a very modular, well-formed profile. And, identifying concerns and identifying what is driving you to do this. There's probably lots of different compliance documents for airworthiness and surety for MOSA. Going through those documents and finding the key things that make you do something different. And then this is the physical capturing of it in a model, and then making sure that it's well formed, it complies to our catalog, it can be kind of vetted across the services for reuse, and getting some consistent results. Jean Shreve will talk later about, hey, when you use UAF or SysML, well, there are different reasons why you would use one over the other. There are certain areas where you could use either, but there's there's reasons why you would use one over the other, but we're addressing those different different approaches. So here you can see that our OAD, the objective architecture description of the system that needs to be acquired, is really, probably we break that up into two kind of lumps. One is that context of the system, the system's capabilities and operational scenarios, its context, its use. That lower level piece is really the logical system and with all the constraints. It's the specification model, and then you can see the bottom piece is the answer, and there could be one-to-many answers, and there's a different approaches there, and we're trying to get documentations from some of the participants on how you're doing it right now, like within Northrop Grumman or in Boeing or at Lockheed, and why do you use one over the other? There are some surveys out there that says here are 5 different ways, but we want to see what's the best way during acquisition. And so in summary, I'm not going to read this slide to you. I want to just jump to the takeaway here. Model-based acquisition is not just about taking the existing stuff and shoving it into a model. It's about using a different process that gets you a better product, to communicate better with your suppliers, and to be able to use that to make informed decisions, and to make sure that they think about how they're going to evaluate these things before they put them out. Like, you don't just put it out there and think you're going to get responses back that you can actually do anything with it if you hadn't. And what this will also do is focus on the solution and moving us towards a more digitally born systems. So with that, is there any questions? All right.
Great presentation. I like the fact that you ended with the systems thinking mantra of, start with the end in mind. And having been on a ACAT 1C source selection, I can't agree with you more. I am kind of curious. Your talk made me think about at least 3 types of readiness that's really big. And also, I think it's Calavelli was telling the industry stop lowballing us on these space acquisitions and tell us how much it's really going to cost. So there's technology readiness, there's manufacturing readiness, and there's human readiness, amongst others like unit and operational. Could you speak a little bit about the ability to for a bidder to assert what they might consider innovations and being able to manufacture something that they consider no one else can do that would actually bring the system acquisition cost down, even though it's just as technically believed to be technically satisfying other requirements.
Are you saying, like, if, I'm not sure I really understood the question, but like using generative design versus like.
Well, design is not manufacturing. So if someone, like Elon's buying special machines in order to make cars at a faster rate and cheaper per unit than anyone else, but that same car can be built at a higher cost using traditional methods, how is something like that going to be shown, let's say, in an architecture versus, it's like how to versus what is?
Right. So, I'm thinking about Elon, and I'm thinking about like the Tesla, the Tesla 3. What is it? Is it the first one? But yeah. But he took like 300 parts. He worked with Sandy Moreau and Moreau Company, and they got that down to like instead of 300 parts, it was like 3 pieces in the back. We have looked at processes like that for like manufacturing a wing, and I'm sure others have too. How do you represent that in this environment, like in the proposal? I don't know, because we haven't got an example there yet, but someone else have a thought to that? I thought I heard of it.
It's determined by the government in terms of what they, so they've already established themselves. It's talking about and if you're a bidder, in the case of being a bidder, Your secret sauce is in manufacturing, right? You still get the same end product, but the trajectory to get there is different. And that really goes to why their bid or their, their cost proposal is what it is. And on the evaluation side, you just look at GAO and others who complain about overruns and behind schedule. Sometimes it's because of the manufacturing. Now, granted, we never get a chance to manufacture two things two different ways, maybe except for shuttle and flight computers, but
Actually,
something came up.
About it now that so when you're thinking about like a fly out range for a KPP, we have to show evidence that we can get there with, 2 engines or 1 engine or whatever. We have to kind of show that, yes, we can get there. And here's the analysis we made. We use this simulator. We use these inputs. We've got these outputs. For the manufacturer, we could do something maybe similar when they look at the cost and think there's no way. But maybe we have to show them the evidence that if we use this manufacturing process, this is our cost. So it might just be down to showing the evidence in the evaluation of how we're going. I'm not sure that exact, but I could bet you we can do it.